Hi there, this is Professor Eckhouse, and I'm going to show you today how to add and subtract radical expressions. So just to warm up from the last lesson that we had, pause the video and try these two problems, see how well you can do. All right, so hopefully you gave those a try. So this first one, again, these are just like a puzzle, really. See them as a puzzle. I'm going to put the numbers together underneath, and I see that I have a 5 and an 80. And 80, I'm just going to check right now on my calculator, is, it's divisible by 5. So try that, and you get 5 times 16. So you might not have all these memorized, and that's fine. You have a calculator, most likely, in your hand. So 5 times 5, the square root of 5 times 5 is, you're going to pull that out, and that is going to become 5. The square root of 16 is going to become 4. Okay, so square root of 5 times 5 is 5, square root of 16 is 4, so we're done with that. And now we've got the square root of a to the 7th times a is a to the 8th. So I took both this one and put them together. Remember that this a has an exponent of 1, and you add the exponents when multiplying. So these can be together under, you can move things around. So the numbers are together, the letters are together, or I could have done this, I'll get rid of this, and I could just make this one big radical. It doesn't really matter how you do it, just however you see it best. All right, so now we're square rooting a to the 8th, and square rooting means basically 8 over 2, like that in the exponent. That's the exponent rule for roots, and so we get a to the 4th. Another way to think of it is this can be split up in a to the 4th times a to the 4th, so we have 2 of them. So now the square root of that is a to the 4th. So now we get, that's a to the 4th. So we get 20 a to the 4th. All right, the next one, we've got a 3 on the outside. So I'm going to pull this 3 out to the front so it's kind of out of the way. And then we've got this cube root. I'll do one big one this time. So I've got a cube root of 64. And then I've got b squared and b to the 8th. That's b to the 10th. And then I've got z to the 1 and z to the 5 multiplied together, and that's going to give me z to the 6th. All right, now when we're cube rooting, remember we're looking for sets of 3. The cube root of 64 is 4, so it's going to come out as a 4. So I get the 3 that was already out here times this new 4 that comes out. All right, so I'm going to do a little work here to talk about these next two. You can use exponent rules, but if it's not divisible by 3, it's just a little bit more challenging to think of it that way. So I'm going to pull out a b to the 9 times b to the 1. That gives me b to the 10. Now b to the 9 is divisible by 9 is divisible by 3, and 6 is divisible by 3. So now if we use the exponent rules, this is b to the 9th to the 1/3 power, which is b to the 9 over 3, which is b to the 3rd. Same thing with the 6. You take the 6 and divide it by 3. So what I have left here is I'm going to bring this out and it becomes b cubed. I'm going to take this out and it becomes z squared, and this is stuck on the inside. So let's put this all together. And on the outside, we get 3 times 4. So I'll just write 12. 12 b cubed z squared. Whoa. Z squared. And then that is times the b that is stuck inside. It can't come out because it's less than a power of 3. All right. So today we're going to look at how to add and subtract, and you have to know how to do what we just did to be able to add and subtract things that don't look like you're able to add and subtract them. But let's start with adding and subtracting basics. So we need to know what the index is and the radicand. So when we talk about this, we can use the words. So the index is just the root, what root it is. The radicand is the whole portion that is underneath the radical sign. So it's going to be really helpful to think of the radical as a variable and treat it like one. So when you add radicals, for instance, 5 square root of 7 plus 3 square root of 7, the square root of 7, treat it like a variable, and we've got 5 of them here on the left, and then 3 of them on the right. When we add those together, we get 8 of them. 8 square root of 7s, if you want to think of it that way. Okay, So that's what I mean by treat it like a variable. Now, this is like having an x and a y. The square root of 2's are common terms, and the square root of 3's are common terms. So we can combine these two, and we can combine these two. All right, so I will rewrite this time so that we can see them side by side. 3 square root of 2 plus 7 square root of 2 plus 5 square root of 3 plus 2 square root of 3. So these were the two yellow ones, and these were the two purple ones. All right, so now we're going to combine them. This here becomes 10 square root of 2, and these two become 7 square root of 3. And that is as much as you can do. You cannot combine those anymore because this is a plus sign. I'm just going to have to fix that because that just looks awful. A plus sign between those two. And not a multiplication. So if it was multiplied, yes, we could combine the two radicals, but we cannot when it's added. All right, so you try that one. Pause the video and give it a try. All right, so we've got a square root of 5 here. We've got a square root of 7 here. We can't combine those, but we can combine the like terms. Okay, so these two can be combined, and the other two can be combined. So we've got 8 square root of 5 plus 2 square root of 5, that's 10 square root of 5. And then we got 3 square root of 7 plus 2 square root of 7, that's 5 square root of 7. So 8 plus 2 is 10, and then 3 plus 2 is 5, and we get that as our final answer. So that's as much as you can do, and you are done with that. There's no more you can do to combine those. All right. So this one, now we are having variables in there. So these two are like terms. This one is not, and it has nothing to combine with. So the first two here are going to combine together, the 3 and the 5 square root of x. So we get 8 square root of x. And then we're still left with this 2 square root of y. So we've got this one and this one. And that's our final answer. All right, next. Now we've got x as the radicand, right? So before, this one right here, we had an x radicand and a y radicand, so we couldn't put them together. Now this one, the x is the radicand every single time, right? So that's the same. But this one, the middle one, has a cube root. So those are not the same as the square roots. We cannot combine them when we add in any way. We can't combine them when we multiply either because they have a different index. So we've got 2 square root of x plus 3 square root of x. Those are the two yellow ones. And then we've got the 4 cube root of x. And that one's all by itself. All right, so now we're going to have 2 plus 3 is 5 square root of x plus 4 cube root of x. And that's the final answer. You cannot combine that anymore. All right, the next one. This one, I've got a square root of x, I've got a square root of xy, and I've got a 4th root of x. So there's nothing more I can do with that. It is as simplified as it will get. So the question is the answer. All right, so simplifying a radical means to pull out, that's what I call it, pull out all the numbers and variables that can come out from under the radical. So if something is, if you have a square under a square root, you pull it out, it becomes an x. If you have a perfect cube underneath a cube root, you pull it out, it becomes an x. So if I had 2 to the 5th under a 5th root, I would pull it out, it would become a 2. So that's what I mean by pulling out. Pull it out. Sometimes you are going to need to simplify before you can add and subtract. Before you can add and subtract. Okay, so let's do a reminder of simplifying with numbers. So this should be a little review, so give these two a try. All right, so hopefully you gave this a try. 75 breaks down to be 25, which is a perfect square, times 3. 25 is, since it's a perfect square, we can take the square root of it. It's going to come out and become 5. So this becomes 5, and then the square root of 3 is still underneath. 5 square root of 3. That's the final answer. All right, the next one is a cube root. So you want to find a perfect cube underneath there in the 135, and that is 27. 27 times 5 gives us 135. So when we cube root the 27, it becomes a 3. So this is going to give me the 3 that comes out, and then the 5 is still stuck underneath. So we've got 3 on the outside, and then cube root of 5. All right, let's try a couple more. So pause the video and give those 2 a try. They're both square roots. All right, so 48. If you try a few things, I always try the perfect squares. I mean, you know, perfect square is 4, and the next one is 9. 9 doesn't go into it. 16. 16 goes into it. So I get, and 4 goes into it too, but get bigger if you can. So I get 16 times 3. So the square root of 16 is going to come out and be a 4. So the 4 comes out front, and that is times the square root of 3. All right, the next one, you will see that 4 goes into 12 3 times. So now this 4 is going to come out. You got to take the square root of it. It becomes a 2. So that 2 will be here on the outside, square root of 3. And now here's how you check. Grab your calculator and take the square root of 12. And then take 2 times the square root of 3. Do you get the same decimal answer? And if you do, you did it right. So it's a great way to check. All right, so now we're getting into simplifying and adding. Okay, so these are going to start fairly simple and they're going to get more complicated. So the first one, we cannot add these because they're not the same under there. So we can't add them. But the first one, square root of 8, is simplifiable, right? Sorry, the second one, square root of 8. So 3 square root of 2, there's nothing more I can do with that. Square root of 2 doesn't simplify, but square root of 8 can be 4 times 2. Well, 4, we can take the square root of that and it comes out front. So let's rewrite this and we get 3 square root of 2 plus, now what came out was a 2 because square root of 4 is 2. So 2 on the outside, square root of 2. So now they are the same, square root of 2 and square root of 2. So I've got 3 of them plus 2 of them gives me 5 of them. 5 square root of 2. Okay, so that is how you add. Pause the video and give the second one a try. All right, so 45, definitely not simplified because I know 9 goes in to 45. So I'm going to come on down and just keep working on this one so we can do one at a time. So the 9 is a perfect square. It's going to come out and be a 3, right? So it's going to come right out there. So the 3 is out front, and then we've got square root of 5. All right, now we've got the square root of 405. So try some things. It ends in a 5, so divide it by 5 and see what you get. And I get 81. Ah, a perfect square. All right, so now you're going to do the same thing. Take the square root of this. It comes out. It becomes a 9, right? So the 9 is now in the front. So put the 9 out here, and we get times the square root of 5. And look at that. Voila. These are what I'm going to give you, things like this. So that you can see that when you have the same radicand and the same index, they both have to be the same, the index and the radicand, you're going to get 12 square root of 5. That's the final answer on that. All right, let's try 2 more. So let's do this one first. And these are cube roots. So we're going to do the same thing we were doing up above with cube roots. Pause the video, give it a try. All right, so this 3 is out front. I'm going to write it in orange just so we remember that it goes out front. And I'm going to leave a little space so I can work with this 32. So 32, what goes into 32? 8 goes into 32, and 8 is a perfect cube. So like I said, know your first 5 are so perfect cubes. I've said that in past classes. So 8 times, that's not the right one. No, 8 does not go, oh, sorry, yes. 8 goes into 32. 8 times 4, sorry, I got lost in what I was doing. 8 times 4, so the 8 is a perfect cube, and that is going to come out as a 2. Okay, so I'll rewrite it down here. We've got 3 times 2 with a cube root of 4. So that becomes 6 cube root of 4. Now I can't take the cube root of 4. I could take the square root of it, but not the cube root. All right, so I'm just double checking here because I feel like I made a mistake. Nope. Okay, so now we've got the cube root of 108. So can you think of any perfect cubes that go into 108? And I think of 27 just to check. So put in your calculator and you do find that 27 is times 4 and gives 108. So that's the cube root is what we're looking for. So if you took the cube of 27, you would get a 3, right? So let's bring that 3 out front. So we get the 3 out here and a cube root of 4. Look at that. They are the same. This one and this one are the same. That means we get to add this 3 cube root of 4 to the 6 cube root of 4, and I get 9 cube root of 4. So add the orange parts and you get the 9. In fact, maybe I should put the 9 in orange so it's really obvious where that comes from. All right, so let's try one more. Give this one a try. It's a square root, so it's a little simpler. All right, so there's a 4 out front. I'm going to do it in orange so we keep track of what's in front. And then the square root of 75. Now, we've already done 75, so you might want to look up, or you can try it again. So the 25 comes out as a 2. And I'm crossing it out so I don't forget. I have square rooted it and brought it out and wrote it there, so I wanted to cross it out. All right, so now I get 3 times 2 is 6, and that is the square root of 3 on the inside. All right, now on the other one, I've got the 2, and I'll put it in orange because it's out front. And I'm going to leave a little space so I can bring stuff out. 48 is, let's see, what is 48? It is 16 times 3, and the 16 is going to come out. Double checking because I'm doing this as I go. 16 is going to come out, and I get times 4. And what I have left on the inside is the 3. So now I have 8 on the outside and the square root of 3. All right, so now the 6 and the 8 add together to be 16, and then we have the square root of 3. Nope, not 16, 14. I wrote it right. I said it wrong. 14 square root of 3. Just making sure I didn't make any mistakes because I feel like I did. Somehow I got 20 on the outside before. Bring that out. I don't think that is right. So hopefully, yep, I think I did. Okay there. Oh no, I know I messed up. I messed up. I can't redo these videos, so I'm just going to talk about it. What is the square root of 25? It is not 2. So I'm going to fix all that. Square root of 25 is 5. So this is 15. 3 times 5. And I also wrote that wrong. Man, I'm tired. Oof. Yeah. Wish I could just undo that and redo it, but I can't redo videos. I use the iPad to do this. So I've got 4 on the outside, not 3, and then square root of 25 is 5. So there we go. Oof. All right, so that becomes 28. 28. Now, if I had checked this on my calculator, I would have caught my mistake. If I took this and I put it in, and I find a decimal, then I take this and put it in and find a decimal into my calculator, I will find that the 2 decimals are the same. And if they're not the same, I made a mistake. So that would have caught that mistake if I had stopped and checked. All right, so subtracting radicals is the same rules as the adding, but you just have to be careful of signs. So try the first one. All right, so you've got the square root of 11 and the square root of 11. So radicand and the index are the same. So we take 9 minus 3 and we get 6 square root of 11. All right, the next one, we've got cube root of 3a every time. Double check, they're all exactly the same. The index is the same and so is the radicand. Don't forget that there's a 1 here, even if it's not written. Sometimes it'll be there, sometimes it won't, depending on the problem. Simplified, it's not actually going to be there later as things get more advanced. All right, so I've got 6 minus 1 is 5, minus 2 more is 3 cube root of 3a, and that's the final answer. All right, let's try the next one. This is a little more complicated, so we're going to have to do each one separately. So let's do 2 square root of 45. So we're going to have 2 square root of 9 times 5, and that is going to bring the 9 out is going to be a 3. I'm being more careful now. And so on the outside I get a 6, and on the inside square root of 5. All right, the next one is 4, and I'm going to put this one in orange. I should have put this one in orange too. 4 times the square root of 252 is 36 times 7. So try your perfect squares and see what is divisible by. You know, start with 16 and then go up to 24, well, not 25, then go up to 36, and you will find 36 goes in 7 times. So we're going to bring this out, and it's a 6, 4 times 6, and that's going to go away in there. So I get, on the outside, I get 24, and under the radical is still, the 7 is stuck there. All right, the next one, we've got 3 on the outside, and then square root of 20 is going to be 4 times 5. So the 4 will come out and be a 2, 3 times 2. And then the last one is minus, I'll do this one in orange just so I'm staying consistent, square root of 7. There's nothing more I can do with that. All right, so I'm going to go ahead and fix this so I don't have to rewrite the whole thing. I'm going to fix this 3 times 2 to be a 6. So this 3 times 2 is 6 right here. All right, so now I've got square root of 5 and square root of 5 right here. And then I've got square root of 7 and square root of 7. So 6 plus 6 square root of 5 is 12 square root of 5. Or 5 square roots of 5, if you want to think of it as multiple square roots of 5. There's 12 of them. And then the purple ones, I've got 24 minus 4. So that's going to be 24 minus 4 is 20. And then the square root of 7. And there's a final answer. All right, one more to go. Let's see, so we've got 5 square root of 24, and that is going to give us 5 on the outside. And then square root of 24, we've got 4 times 6. The 4 then is going to come out and be a 2, 5 times 2. So I get 10 square root of 6. That's the first one. All right, plus, I don't need to write the 1, really, so I'm just going to put square root of 70. 75 is 25 times 3. All right, the 5 is going to come out from the 25, so that becomes a 5. All right, so I get, in this one, I get 5 square root of 23. Sorry, 3, square root of 3. Minus, now let's check this one, 294 for perfect squares. You just want to use a calculator probably, and you'll find, if you play with a few numbers, get up to 49, and it goes in 6 times. All right, so the 40, and again, there was a 1 out front, which I'm not going to bother with. So this 49 comes out as a 7. So I should have written that right up above. Let me write that up above. I'm just trying to figure out why I ended up with that down here. And it's because I dropped down to the bottom one. So I'm going to write that so I get the 7 on the outside of this lovely thing. And the 49 had gone away and became the 7. All right, so let's make this a little tidier. All right, so now we've got, let's tidy this up and get the 7. And then that is times the square root of 6. All right, now we've got a minus 2. Do that in orange, so they all go together. 2 square root of 6. All right, so now we're going to add and subtract the orange numbers, but we've got to find the like terms. 49 times... Then we're going to double check something. 49 times 6 is 294. Okay. Just wanted to see if I missed that there was a 3 somewhere. 75 and 3. Okay. So, and then, oh, no, that's what I messed up. I knew there was 2 square roots of 3. Yeah, this is what happens when you record way too late at night. So hopefully you guys saw that mistake. This is a square root of 3 right here. I had a 6. I was looking at my 6's and I wrote a 6 when I meant a 3. All right, so that was this one right here. I just needed to rewrite it. I didn't rewrite it right. All right, so now continuing on, we've got square root of 6, square root of 6, and we've got square root of 3, square root of 3, and we're going to combine those. So 10 minus 7 is 3 square root of 6. That's the yellow one. And then the 5 minus 2 is going to be a positive 3 square root of 3. So that one is the purple one. And that is as much as we can do with that. Square root of 6 doesn't simplify anymore, and they can't be combined. All right, I believe that is, using the distributive property, right? Okay, so this is the last topic. So we're going to distribute these just like we distribute everything else. So this A gets distributed times this and times this. So practice that before we do it with square roots. All right, so you should get 5a squared minus 7a. I just multiplied it times both of them. So we're going to do the same thing with a square root. So this square root right here, square root of x, gets distributed across this one and this one with a minus inside. So I'm going to write it all out, but I get 2 square root of x times the square root of x minus 7 times the square root of x. So that's our square root of x that just got multiplied by both of them. We write square roots last after numbers, so I put it at the end. All right, so square root of x times square root of x is square root of x squared, right? So these two right here become square root of x squared, or another way is square root of x times x. We've talked about that a lot already. That's just x. So we get 2x minus 7 square root of x. So be careful with these. There's a lot of places to mess up. All right, so let's try this one. All right, so I'm going to distribute 2 square root of x times everything. So I'll just write it first because it's got a number with it. So 2 square root of x times 5 square root of xy plus 2 square root of x times square root of y. Now remember, these are all just multiplied together, and so are these. So I can combine everything as needed. So these two combine to make 10. And then I get the other stuff underneath the radical together. So I get the 10, and then I get the square root of x times y. Now what happens when we get x times x under a radical? It comes out and just makes an x. So this becomes 10x square root of y. That's the first term. All right, plus the second term, we've just got 2 square root of x y, like that. So we can just bring that down, plus 2 square root of xy. Now the radicand is different. Y and xy are different. So I colored a different color because they don't go together. Same index, but different radicand. All right, let's try, I think this is our last one. All right, so one step at a time. Don't get overwhelmed by the numbers. Just take it, be careful. All right, I'm going to put this last because it doesn't have a number with it. So I'm just going to put it at the end of each one. So I've got 3x cube root of x squared times cube root of x minus, it doesn't really matter what I put first here, but cube root of x to the 5th times cube root of x plus 6 cube root of x to the 8th times cube root of x. So let me color all of the ones that I distribute that times each one of the terms that were up above. Double checking everything. All right. So now I'm going to have here cube root of x cubed. 3x cube root of x cubed. All right, now here I'm going to have cube root of x to the 5th times x, which is x to the 6th. Plus the last one, I'm going to have 6 cube root x to the 8 times x to the 1 is x to the 9. All right, so let's work on this. Cube root of x cubed becomes x. All right, so we've got 3x times x. Now I've got cube root of x to the 6th, and remember the rule then is going to be x to the 6th over 3, which is x to the 2. So that gives me, this comes out as x squared. Now this one here, cube root of x to the 9th is x to the 9 over 3, which is x to the 3rd. So this one comes out and becomes x to the 3rd and we've still got a 6 out front, plus 6. All right, so I've got 3x squared minus x squared plus 6x cubed. Let's write this in descending order and combine like terms. So these two combine, and the descending order means the first one has to be the 6x cubed because it has the highest degree. 6x cubed plus 2x squared. And that's the answer to that. I believe that that was the end. Sure enough. Thanks for watching.